Welcome to today's Explainer. We're jumping right into a super fundamental concept in physics and plant engineering, absolute pressure. We're going to demystify what it actually means to measure the absolute, true pressure of a system. And to do that, we'll look at its trusty sidekick, gauge pressure, to help us really nail down the difference. Let's get right into it.
So to really wrap our heads around pressure, I want to kick things off with a question. It might sound like day one physics, but it totally sets the stage. If air has weight, and it absolutely does, it's packed with molecules, why don't we feel it? Think about it. You hold out your hand or look at an empty plastic water bottle sitting on your desk. It doesn't feel heavy, right? It's not getting crushed, but we are literally sitting at the bottom of an ocean of air, miles deep, pushing down on us right now. The reason we don't feel it, we evolved right in the middle of it. Our bodies, that empty bottle, they are completely equalized to this environment. The air inside the bottle is pushing out with the exact same force the outside air is pushing in. It's basically our natural baseline.
In that magically invisible baseline, it actually has a name. We call it atmospheric pressure. It is the invisible, constant weight of the air above us just pressing down on everything. In standard engineering terms, this pressure is roughly equal to 1 bar. To put that into perspective, it's kind of like having the weight of a small car pressing down on every single square meter around you. Crazy, right? So even when we look at an empty room or an open pipe and think there's zero pressure in there, it's actually sitting right at 1 bar of atmospheric pressure. We just treat it as our natural zero because we are so incredibly used to it. Grasping this baseline is absolutely crucial for unlocking the rest of this explainer.
Okay, let's bring this into the kitchen. I love this analogy because it takes a really technical engineering concept and makes it instantly click for beginners. Imagine you're baking and you need to weigh out some flour. You're not going to just dump the flour straight onto the scale, right? That makes a huge mess. First, you put an empty bowl on the scale. The scale reads the weight of the bowl. But you don't care about the bowl, you only care about the flour. So what do? You hit that magic little tare button. Boom! The scale resets to 0, completely ignoring the bowl's weight. Then you pour in the flour, and that number you see, that is purely the weight of the flour.
This kitchen trick is literally the perfect way to understand our two pressure types. Let's map it right onto the engineering terms from our source material. Absolute pressure, that is like weighing the bowl plus the flour. It includes the whole shebang. It measures the total, true pressure in a space, meaning it strictly includes the weight of the atmosphere. Now, gauge pressure is what happens when you hit that tare button. It completely ignores atmospheric pressure. It's an incredibly useful shortcut. But remember, it doesn't tell us the absolute true physical stress the system is experiencing.
Let's see how this plays out in a practical thought experiment from the source documents. Just picture a massive industrial pressure vessel sitting outside. It's completely open to the air, nothing is being pumped in, no vacuum is sucking air out, it's totally equalized with the world around it. Now imagine we hook up 2 different pressure gauges right on top of this open tank. One is designed to read absolute pressure and the other reads gauge pressure. So what do you think they're going to say?
Well, if we check the absolute gauge on that wide-open, empty vessel, it doesn't say 0, it reads 1 bar. Why? Because absolute pressure measures the total reality of physics. It captures that invisible weight of the Earth's atmosphere pushing down inside that tank. Just like the scale before you hit tare. It doesn't care that the vessel's just sitting there open. It measures reality. But if we look at the gauge pressure reading right next to it, it shows a clean 0 bar. It's been tared. It just assumes standard atmospheric pressure as the baseline. Since we haven't forced any extra pressure into that vessel above the normal air around us, it reads 0. It's telling the engineer, hey, nothing extra is going on here. But it completely hides that absolute reality of the 1 bar.
Now, we can actually jump between these two measurements using a super simple formula. The source material lays this out perfectly. Absolute pressure equals gauge pressure plus 1 bar. That is it. Literally that simple. So if a process creates 5 bar of gauge pressure inside a closed tank, the absolute pressure in there is 6 bar. And if you ever wanted an absolute pressure of true 0, well, you'd have to travel out into the dead vacuum of deep space where there's 0 atmosphere. Anywhere on Earth, absolute pressure is always going to be greater because it carries that extra 1 bar of atmospheric weight on its shoulders.
So you might be wondering, if absolute pressure is the actual physical reality, why do engineers basically ignore it most of the time? Well, think about designing the steel shell of that vessel here on Earth. The atmosphere is pushing on the outside with 1 bar, and it's pushing on the inside with 1 bar. They just cancel each other out perfectly. The steel doesn't feel any structural stress from the atmosphere itself. The only thing that threatens to pop that tank is the extra, added pressure inside, the flour in our bowl. So engineers use gauge pressure as a super convenient shortcut to focus only on that extra stress. It saves them from having to calculate the absolute totals every single time.
Because both of these measurements pop up in the field, we have to document them really carefully to avoid some pretty catastrophic miscommunications. On an engineering data sheet, if you see a unit with a lowercase g tacked onto the end, like bar G, you instantly know it's gauge pressure. They tarred the atmosphere. But when a process actually requires tracking the true total pressure, engineers use a lowercase a, like bara. That little a explicitly screams, "This is absolute pressure, atmosphere included."
We've covered a really solid chunk of ground today, distilling this totally foundational engineering concept down to the basics. So I want to leave you with a thought to take out into the real world. Think about the stuff you interact with every day, like the next time you're at the gas station checking your car's tire pressure and that little digital screen says 32 psi. Based on everything we just talked about, is that the gauge pressure? And if it is, what do you think the absolute pressure inside that tire actually is? Keep exploring, and I'll catch you on the next explainer.